Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's weekly contest, time to cross a bridge. So this is a bit trickier problem, not in terms of complexity, but rather how to implement this. So during the contest, I was not able to solve this. Basically, I was trying to solve, I read the problem incorrectly, and I was trying to solve a different problem altogether where we need to optimize the time taken to move the boxes from left side to the right, from the right side to the left side. But that was not the problem. The problem is way easier than that. You just need to simulate whatever is given in the problem, and that's it, right? So let's uh, anyway, let's try to understand the problem. So the problem states that there are k workers and n boxes. So the statement is a little bit lengthier, so I would encourage you to read it by yourself. I will just explain this in terms of with the help of this diagram. So there are some workers. So here there are two workers, and there are some boxes. So here there are three boxes, right? So there are two warehouse, new warehouse, old warehouse. Every box is present in the old warehouse. You need to move all these three boxes to the new warehouse. Now, how exactly we will be moving? Every worker is currently standing in the left side of the river. So there is a river, and there is a bridge connecting the two banks of the river. So every worker is currently standing at the left side of the river. Now, what is the journey? The worker would first cross the bridge, right? Pick up the box, and then again cross the bridge, and then drop the box. So each of these operation has some time. So there is a time defined to cross the bridge, which is equals to uh, left to right. And then there is a time defined to pick up the box, which is pick old. And then there is a time defined to cross the bridge from right to left, which is right to left. And then there is a time defined for dropping the box at the new warehouse, which is put new. So each of the worker has this properties defined already. You are given all these properties of every worker. Now what they are saying is you just need to find out what is the time where you can you can transfer all these three boxes to the new warehouse, right? So that's what the problem asks us to do. Now there are some rules around the movement. Let's say there are two workers standing in the left bank of the river. Now it is given the problem that only one worker can cross the bridge at any given point of time. Now if there are two workers here, which one will you choose first? So for that there is a efficiency formula given. So you there is a formula given which the help of which you will calculate which one of the workers would cross the bridge first, right? Now let's say there is another case. There are two workers. One is on the left side, one is on the right side. Now they both are waiting to cross the bridge. Now what would happen? So what they're saying is, in this kind of situation, you would always prefer first the one which is going from old to the new. So basically the one which is going from right to the left, that is the first one to be preferred. So in this particular scenario, if there is a worker standing on the left and then there is a worker standing on the right, you would prefer the right worker and let him cross the bridge first, right? So if there is no worker on the right, then you will prefer the one that is going from new to old, or basically left to right. And if like again, if there are multiple workers, you will start with the one which have the lowest efficiency, right? So that's what the problem statement is, right? Now this is like they just try to simulate whatever we are given, right? So let's say there are two workers, 0 and 1, and the properties of these two workers are defined here. So left to right, right to left, pick old, pick new, everything is 1 for the worker 0, and everything is 2 for worker 1, right? Now currently let's just assume t equals to 0, right? And there are three boxes that we need to transfer from old to the new. Now let's just try to simulate. So at t equals to 0, every worker is starting on the left bank of the river. Now they both are waiting to cross the bridge, right? Now efficiency wise, you can like this is the formula given. So basically efficiency of 0 is less than efficiency of 1. So sorry, efficiency of 1 is less than efficiency of 2. So 1, if 0 and 1 both are present at any given side of the river, we would prefer 1 over 0, right? So like that, this is for, you can calculate this with this formula very easily, but that's what the problem states. So efficiency of 1 is always smaller than efficiency of 0. So if 0 and 1 both are there, you will prefer 1 over 0. Now, what would happen at t equals to 0? At t equals to 0, because efficiency of 1 is less, it will cross the river. Now, how much time it would require for uh, worker 1 to cross the river? 2 units, right? 2 units of time. So after 2 units of time, the worker 1 would be at the right side of the river. So basically, at t equals to 2, this is the state, right? Now, what happens afterwards? So at this point, the bridge is free. So what happens at t equals to 2? At t equals to 2, worker 1 starts picking up a box from here, right? Now, notice that worker 1 reaches here at time t equals to 2, and it takes 2 unit of time to pick a box. So it will it will require up till 4. It Our worker 1 would be picking up the box up till 4. So at t equals to 4, worker 1 would be at the right bank of the river. So for now t is not 4. So for now t is still 2. So worker 1 is still picking up the box. Now at this in very instant, at t equals to 2, worker 0 will try to cross the river, right? So it will cross the river in 1 unit of time. So at t equals to 3, this would be the state. So worker 0 will cross the river, worker 1 is still picking up the box. So now at t equals to 3, worker 0 also starts picking up one of the box. So now notice that at t equals to 3, worker 1 reaches here, and it requires 1 unit of time to pick up the box. So at t equals to 4, until t equals to 4, it will be picking up the box, right? So now let's say time is now t equals to 4. You just increment, we are incrementing time one by one, right? So now let's say that it is t equals to 4. So if it is t equals to 4, both worker 1 and worker 0 would have picked up the box, right? And they both are now waiting on the right side of the river. Now because they both are waiting, we will prefer worker 1, right? Because of efficiency. So worker 1 will cross the river. It takes around 2 units of time. So at t equals to 6, this is the state, right? That worker 1 has crossed the river. Now worker, like, what happens at t equals to 6? Worker 1 will start putting up the box here, and at the same instant, worker 0 will try to cross the river, right? Now what happens at t equals to 7? At t equals to 7, worker 0 would have crossed the river, right? And worker 1 is still picking up the box. Notice that worker 1 reaches here at t equals to 6, right? So worker 1 would be putting in the box until t equals to 8. So until t equals to 8, worker 1 will be here. Now worker 0 has reached here at t equals to 7. So worker 0 will start putting the box at t equals to 7, right? So worker 1 require 1 unit of time to put the box, right? So it reaches here at t equals to 7. So until t equals to 8, it will keep putting the box, right? And notice that we have removed 2 boxes from here. So only 1 box is now remaining. So again, at t equals to, like, let's move forward with the time. So at t equals to 8, what will happen? Both worker 1 and worker 2 would be finished putting up the box, and they both can wait in the river. Now notice that despite they both are waiting, there is only one box remaining, right? So, and you know that among these two, worker 1 would be preferred. So you will just make worker 1 cross the river, and at t equals to 10, worker 1 would have crossed the river, right? And now at t equals to 10, worker 1 will start picking up the box. So worker 0 can start crossing the river, but it doesn't make sense for worker 0 to cross the river, right? Because there is no box remaining. So worker 0 would stay here. Now worker 1 reaches here at t equals to 10, right? So it will take around t equals to 12 for worker 1 to cross, like, to pick up the box. So we will increment the time. Let's say what happens at t equals to 11, worker 1 will be here. We incremented the time at t equals to 12. Worker 1 completely picked the box. So at t equals to 12, worker 1 would be reaching at the left bank of the river again. Now there is no other worker, right? So worker 0 is standing here, worker 1 is standing here, and as we discussed, like, we will prefer the one which are on the right side first. So worker 1 would try to cross the river, and at, like, it requires 2 unit of time. So worker 1 will cross, like, will cross the river by t equals to 14, right? And after this, worker 1 would like start putting the box here, right? And it will put the box until t equals to 16. So until t equals to 16, it will like at t equals to 16, every box is there in the uh, new warehouse. But what the problem asks the time at which the last box crosses the river. So basically, problem doesn't ask for how much time it requires, like to put the last box. You just need to return what is the time at which the last worker, the worker which is carrying the last box, crossed the river completely. So this is our answer. T equals to 4, at t equals to 14, every box would be there on the right bank of the river, or on the left bank of the river from the right bank, right? So now this is how we can simulate, right? So now what is the time complexity to simulate this entire structure? So notice that you need to maintain a queue here, like a queue here. Now this queue should be ordered because among 0 and 1 you would be picking 1, right? So this queue is ordered. So because this queue is ordered, you need a priority queue here, right? So you are maintaining a priority queue for the left bank, you are maintaining a priority queue for the right bank, right? And then you are just incrementing your time, like 1 2 3 4, and just doing the operation. So what happens at given, like let's say at t equals to x, this is the state. Now at the very next state, you will just calculate what will happen at that next stage. So worker 1, let's say, would be crossing the bridge, right? So you will just simulate this entire thing by just incrementing time one by one, right? And what happen, like let's say you increment time by one, what is the worst case that can happen? The worst case can be, let's say there's a worker here which is now started crossing the river. It might not have crossed the river completely, right? So for example, let's say worker 1 started at t equals to 4. Just an example, let's say worker 1 started at t equals to 4, so it requires 2 unit of time to reach here, right? So you just incremented. When you increment 4 to 5, you will say, okay, nothing changed. Worker 1 was crossing the river and now it is also crossing the river, so there is nothing which is changed, right? So basically what we are doing is we are incrementing the timer one by one, and at with every instance of timer, one of these could happen. A worker might have finished his job, sorry, a worker might have finished his job, and because it finished his job, it will be transferred to the right bank of the river. So this is the one thing that can happen. Second thing that can happen is a worker might start crossing the river, right? In that case, you will just increment the timer until it crosses the river, right? Or what the next thing is, worker, there is a worker which was putting the box, it can come back to the left bank of the river, right? So basically one of these things would happen when you increment the timer. So what is the approach is just to keep incrementing the timer and maintain all these four things, like how many workers are there in the right bank, how many workers are there which are putting the box in the left bank, how many workers are there which are in waiting on the left bank to cross the river, how many workers are there which are waiting on the right bank to cross the river. So if you maintain all of these, you would be, and you are incrementing timer one by one, you would be able to solve this very easily, right? But there is a catch. So what is the time complexity of this entire thing? So basically, whenever you increment a timer, you will be doing some constant operations. Like you will be either putting, let's say, some worker was here, you will be putting this worker here, or you will be make it cross the river, or you will be putting this to this particular set or this particular queue. So basically, at if you increment the timer, you will be either adding something to the queue, or you will be removing from the queue, or you will not do anything. So with each increment of timer, you are doing login operations, right? So basically these two are priority queue, so that's why we require login operation. Now after login, like you are doing this for each time increment. So let's say the answer is t, so the complexity would be t login. Now t, can be up to 10 to the power 7 as per the constraint. So basically, let's say they're saying every value can be up to 1000, right? So in worst case, what can happen? In worst case, a worker will keep waiting, and so in worst case what can happen, let's say there is a single worker, and single worker is have to pick every boxes here and has to throw every box here. So if everything is 1000 for one box transfer, see, this worker would require 1000 unit, like 4000 unit of time, like 1000 for crossing from left to right, then picking and then crossing and then putting. So 4000 unit of time would be required for a single worker to do the job of transferring one box. So total there are 10 to the power 4 boxes. So in worst case, 4 into 10 to the power 7 unit of time will be required to do all the job. So basically T can be up to 4 into 10 to the power 7. Now if you multiply log and factor here, this will not pass the time complexity, right? And because this will not pass the time complexity, this solution is not optimal. Like this solution work, like this is very easy to implement. How you'll implement? Basically, we will maintain these four data structures, like these two priority queues, right? And these two vectors or set, whatever you call it. Now, at with every increment, you will see, okay, what can I move something from here to here, or can I move something from here to this queue or somewhere here, or can I move something from here to here, or so on and so forth. Like you will check all of these possible combinations and just move the workers around, and that's all. Like that's all you have to do. And finally, at whatever t you will reach, the last worker will reach the left side of the river, you will return that as an answer. So this works, but complexity is t log n, or if even if you implement, let's say, in more naive fashion, it will be t into n log n. Like you will try this for every worker. So t into n log n if you implement it more naively, but this will not pass for sure. So we need to optimize it. Now, one thing that you should think of while optimizing these kind of situation is, so notice that you are wasting time somewhere, right? So for example, in this case, let's say worker 1 was here at t equals to 3, right? And let's say worker 0 is also here at t equals to 4. Just an example. Now, worker 1, let's say worker 0 requires 5 unit of time, and worker 1 also requires 4 unit of time. So basically, you will be incrementing t, but you are not doing anything. That's the problem. So basically, we are incrementing t, but not doing anything here. So let's say t equals to currently t equals to 4. So what happens at t equals to 5? At t equals to 5, they both will be here, right? Because worker 1 would require 4 unit of time to process this, right? So worker 1 would be here until t equals to 7, and worker 0 would be here until t equals to 9. So basically, you will be incrementing t, but you will not be doing anything here. Like you will not be transferring something from here to here, or transferring something from here to there, and so on and so forth, right? And because you are not doing that, that's the reason you are missing on, like you are incrementing your t, but you are not doing anything. So basically, you are wasting your iterations, and that's where we can't have t here, right? But let's say we somehow make sure that at every tick of the timer, or we do something. Let's say there are total 4 into b number of operations, where b is the number of boxes. So there are total 4 into b movements at the end, right? So first movement would be, some worker would come from here left, like left to right, then it will pick the box, it will come from right to left, and then it will put the box. So for every worker, for every box there are 4 operations, right? So this worker would be making 4 switches. So if, like in worst case, there are 4 into b number of switches, but we are having t number of switches, and that's where the complexity is getting higher. So if we somehow make sure that, okay, at every instant, or at every given instant, we are able to perform one of these operations. So at every given instance, either we can move this to here, or we can move this to here, or we say that, okay, uh, I will move some worker is here, I will move this to here, or some worker is here, I will move this to here. So if at every given instance we are doing one of these 4 into b operation, so we are sure that at the end we will be requiring these many number of operations. So basically the complexity would then become 4 into b into log n instead of t log n, right? And that would pass because b is only up to 10 to the power 4. So this would surely pass. So hope you get the basic intuition. So what we are trying to do is instead of incrementing timer and then wasting timer at a given stage, we are trying to do something which would help us perform one of these 4b operation at, like, whenever we are moving one step, we will be performing one of these 4b number of operations. So at the end of 4b steps we would be reaching our answer. So this t would then become 4b and that would pass the time complexity. So now how to do that? So the basic thing is, we don't need to, or we need to think of how not to waste time, right? And that's that. If we are able to do that, we will be able to solve it. So let's see how not to waste time here. So let's just reset everything, and let's say 0 and 1 are here, right? So at first, let's say there is something in the, so this is the order which you should follow, right? So first you will check in the right priority queue, right set priority queue, that is there something or not. If there is something, you will be moving that to the right side. So you are performing one operation here, right? And that is good, because at one step you want one at least one operation to be performed, one out of this 4b, right? At least one operation to be performed. So if there is something here, you would definitely move it to the left side and you will perform one operation. But let's say there is nothing here, then you will check, okay, is there something on the left side? If there is something here, then again, let's say in this case, you will be moving that particular worker to the right side. So again, you are performing one operation, and that is good, right? So notice, just to reiterate, we have to perform one operation every time, and that's our goal. That if we are able to achieve this, we are done with, like, we have reduced our T to 4B, and that's what we have to do. So what we just saw, if there is something in the right side priority queue, then at that particular state, we are very sure that we can move this worker around, or we can perform one operation. Similarly, if there is nothing in the right side, then you check the left side. If there is something in the left side, then okay, you are very sure that you can move this to the right side, or basically you can perform one operation. Now let's say both are not the case. So let's say there is nothing on the left side and nothing on the right side. There is everything is waiting in the warehouse, like just picking the boxes here. So this is the main point of time wasting, right? So basically we have to, previously we are keep incrementing the timer, but we are not able to perform any operation. So now what we will say, okay, let's say for like this worker 0 finished picking up the box at t equals to 8, and let's say worker 1 finished picking up the box at t equals to 9. So if this is the case, if we know that worker 0 would be finished at 8, and let's say the current t is equals to 3, then why would we want to wait until t equals to 8? We will simply say that, okay, I will directly increment t to 8 and move this worker from here to here. Again, just to make things clear once more, only place where we are wasting time is, like, if there is something on the right side, we will not waste time. If there is something on the left side, we will not waste time. Only place where we will waste time is if all the workers are on the left side or on the right side, like either this case or this case. So these are the only two cases where we will waste time. So what we were saying is, let's talk about the first case where everything is on the right, on the right side. So if everything is in here, we already know what is the end time, or what is the time until which 0 and 1 would be here. So what we can do, we can just pop out the 1, or remove the worker which has the least time here. So we can just increment our time to our time t to 8, and just move this worker to the right side priority queue. And if we are able to do this, then again we haven't wasted time, and instead we have done one operation, and our goal is satisfied. Same thing we will do for the left side as well, where every worker in the right in the left side. So to do this, you need another priority queue here. So what we will need, you will need, okay, what is the end time of each of these worker. So you will let's say calculate 8 and 9 at the end time. So you will maintain this in the priority queue, and you will just pop out the one which is the least end time. Now why priority queue and why not simple queue? Because let's say there is a worker which comes here just now, right? There's a worker which comes here just now. So if this worker comes here just now, and let's say this worker would be able to pick the box very fast, in let's say at until t equals to 5 it will be done. So because new worker can be the value of new worker can be smaller than any of these, so you have to put 5 at the correct place, right? And that's where this queue will also not be a simple queue, instead it will be a priority queue. Now there are four priority queues now. First priority queue to maintain the uh, workers on the left side of the river. Second priority queue to maintain the workers on the right side of the river. Now notice that these two priority queue are sorted by efficiency, right? And then there are two more priority queues. One, workers which are waiting on the right warehouse, then workers which are waiting on the left warehouse, basically waiting for picking the box or putting the box. So these two priority queues will be sorted by time. What is the time remaining or time to finish? So time to finish for this worker is, let's say, 5, so you will just put 5 here. Time to finish for another worker is, let's say, 8, you will put 8. Time to finish for another worker is, let's say, 3, you will put 3 in the beginning, and so on. And finally, if nothing is there on the left side or on the right side of the river, you will pick one or pick the top from here and increment the timer to that, and just move this to the right side priority queue, and same for the left side as well, right? So hope this all makes sense. If you have any doubts, I would strongly encourage you to rewind the video, and I'm very sure you will be able to get it. So let's look at the code that would make things much more clear. So we have like I just made these two structure just to make code a bit simpler to understand. These two are not required. You can just simply use simple priority queues as well. But uh, I have made this bridge worker and W house worker. So bridge worker is sorted by efficiency. W house, which is warehouse worker, is sorted by timing, right? So warehouse worker has something called finish time, and it is sorted by finish time. And bridge worker has something like is sorted by efficiency. So these are the two structure that I've made. Now we maintain four priority queues as we said, two for bridges and two for warehouse. Then we put everything on the left bridge initially. So BL is the left bridge, WL is the left warehouse, and similarly BR is the right bridge, and WR is the right warehouse. So we put everything on the left bridge first, right? And then we currently our time is 0, and this vector denotes the time of crossing for each of the boxes. So I'm keeping track of what is the time the first box cross the river, like first box comes here, then what is the time second box comes here. I'm tracking this, but it's not required. It is just for explanation purpose, or for debugging purpose. If you are, let's say, you want to debug this in an online contest, this is how I would have done it, right? So now what we are doing is we are checking until we have some boxes. Now we will look at where we are incrementing where we are decrementing the boxes, but basically this while loop suggests that until there is some boxes on the right to take, right? So what we are doing initially, as we discussed, we will first check if there is something on the left side, or something on the warehouse which can be put here. Let's say the current time is 8, right? And there are these three workers are in the right side warehouse, which has finish time of 358. So previously we are incrementing time one by one, and because we were doing that, we are sure that at every given point we will be moving something to the right side if required. But now time is getting jumped, like from 3 to 8 or from 9 to 15 and so on. So because of this, it may happen that there are some workers here which are already done because of time increment, right? So the first thing that we check is, okay, how many workers are already done. So current time is, let's say, t. So how many workers are already done? So we'll just keep on popping elements from here until they are less than equals to t. So that's what like we have done. Like we keep on popping here and put it to the right queue. And same thing we'll do for the left side as well. We'll keep on popping elements from here and put it to the left queue until the finish time is less than t. So the first condition, let's look at the first condition. It says we are checking the left warehouse. WL is the left warehouse. We are checking if it is not empty, and current time is greater than whatever is the finish time of the topmost worker there. If the finish time is smaller than the current time, it means it has already finished. And because it has already finished, it is the time to move this worker to this queue, right? So this condition is something we will look at, but basically this is the condition we are checking. Basically, if it is not empty and if it is past current time, then we will simply push this worker to the bridge L, or left side of the bridge. So what we are doing, we are just popping it from the top and then just pushing this W in BL, right? So after this, again, for the right side, we will do the same thing. If it is not empty and current time is past the topmost element there, then we will pop it and then push it to the right bridge. Notice that we have pushed it to the left bridge first, and then in this case we have pushed to the right bridge. So now what, till now what we have done, we have pushed, we have corrected our current state. So because there can be some jump in t, so we have just ensured that because of this jump, we have corrected our state. Whatever workers are done, we have moved them to the left side or right side or the left side based on their time or time to finish. Now, after that, we have to apply this logic, right? We'll just first check whether there is anything on the left side, on the right side. If there is something, some worker waiting on the right side, we will make them cross the river, right? Otherwise, if there is nothing here, we will check for the left side. If there are some workers on the left side which are waiting to cross the river, so we will, if there are, we'll make them cross. So let's just first look at these two condition. So we are first checking whether BR is empty or right bridge is empty or not. If right bridge is empty, it means it's not empty. It means there is some worker working here, some worker waiting here to cross the river. So in that case, we will just pop the topmost worker. So again, this bridge worker was sorted by the efficiency. So this top would give us the one which have the least efficiency, right? So because we have just crossed something from the right side, so this worker should have taken one box, right? And this one box is now crossed the river to the left side. So we decremented the boxes, and we also incremented the current time to right to left. So because notice that this worker is crossing the river. Now there is only one worker that can cross the river at any given point of time. So until this worker is done, no other worker can cross the river. Again, there can be some workers which are waiting here and they might come here in this middle timestamp. But that thing we are taking care by just moving them in the beginning of the loop, like that we have taken care. So at until current time there are no more changes. So now we just pop the first one, reduce the number of boxes, and then incremented the current time with the time required to go from right to left, and then also push this to our vector, because as mentioned, this vector denotes the time for each boxes. So we just push the current time in this vector, and we then push this to the warehouse of the left side, right? And in the warehouse of the left side we put it as the finish time is now current time plus put new. So current time is whatever time the worker was here, and let's say worker requires 2 unit of time to put the box. So we just add the 2 unit of time, and this entire thing is now the finish time. Is now the finish time of the worker. So after this, we, let's say there is nothing here. So again, once we have done this, we have performed one operation. This is our goal. We have to perform at least one operation in one go. So we have performed one operation. So we just continue. So we continued from here. Now after this, if let's say there is no empty here, so then we'll check whether this part is empty or not, whether there are some worker waiting on the left side to cross the river or not. If there are some worker and there are some boxes left or not, so basically it doesn't make sense to make the worker cross the river just like just for nothing. If until there are some boxes left, you will not want the worker to cross the river, right? So how many boxes are transferred? So whatever boxes were transferred, we have already decremented that, right? Now there are some workers waiting in the queue and some workers waiting in this queue, right? So number of workers waiting in this queue and this queue have already picked boxes each. So let's say there are four workers here, there are four workers here, and there are three workers here. So if in this particular case there are like seven boxes which are outstanding. So if number of boxes left is greater than 7, or number of outstanding number of boxes which are yet to be moved is greater than number of boxes which are already assigned, then only we will make the worker cross the river. So we'll just make the worker cross the river by incrementing the current time to the time required from left to right, right? And once this is done, again we have done one operation. Like this is our goal, we have to perform one operation at least. So we just after we have done, because we have jumped at the time, we will not move forward, and we will why we are not moving forward, because we have jumped the time. So there might be some workers which might have already done their task from here or here, right? So we have to like rearrange the state. So that's where we are just continuing. And why this continue would work, because we have performed one operation and that is our goal. Like we have to perform at least one operation in one go. So that's why this continue would work and would not increase the time complexity, right? Now let's say there is nothing on the left side or nothing on the right side, or there is something on the left side but they don't need to be moved to the right side because there are no more boxes. In this particular case, what could be the situation? The situation could be everything, like there are some workers waiting on the left warehouse queue, some workers waiting on the right warehouse queue, right? And this is the time where we have to make another jump of time. So basically, let's say current time is 8 and there are, let's say, two workers here. First worker has finished time of 9, and second worker has finished of 10. And there are two workers here. First worker has finished time of 8, second worker has finished time of 9. So which worker will you pick first? So we will just see whatever is the minimum here and whatever is the minimum here among these two. Whichever is the first minimum, we will make that first move to there, right? Because that would be the first move. Among 8 and 9, among 8 and 9, 8 at time t equals to 8, this worker will be done, right? So we will just make this move and move it to the left side of the queue. And notice again, we don't need to move 9 as well. So let's say there are two 8, there is one more 8 here. You don't need to move both the 8s here, because our motive is to perform at least one operation, right? So this 8 can come in the later operation. So just if they are both equal, it doesn't matter, you just move any one of them. So that's what we have done. We have checked what is the finish time, the minimum finish time in the left side. We have checked what is the minimum finish time on the right side. So if there are no more workers, we just mark it as very high number. So notice that the highest number was 4 into 10 to the power 7, and 1 to 10 to the power 9 is higher than that. So that's the reason of putting 10 to the power 9 here. Now we will check which one is smaller. If left is smaller, move we'll remove the worker from the left warehouse and put that in the left bridge, and then increment the time, or the current time would become the left finish time, right? Similarly, if they are not less, like if right one is less, you will do the opposite. You will remove from the right warehouse and put in the right bridge, and then move fast forward the time to right finish time. So after this loop, like notice that we performed at least one operation here, at least one operation here, or at least one operation here. So at every time entering this loop, we are performing at least one operation. So this loop can go up to 4 into b number of times at the worst case, and hence the complexity is 4 into b into log n. So hope this makes sense. If you have any doubts in the problem, please post them in the comment section below. I will be happy to answer. I would strongly encourage you to code this solution yourself again. Even though you have understood every piece of the problem, I would encourage you to code it yourself, because this kind of problem will help you strengthen your implementation skills, which is required in some coding challenges while giving some interviews or in online contests as well. So I would encourage you to do that. Again, any doubts, please post them in the question below. I would be able to answer. And then if you like the video, give it a thumbs up and do subscribe if you haven't already. And I will see you in the next one. Thank you.